Hello everyone, my name is Rasan sir, and we are going to present the final report for the empirical analysis. And as we did in the increment one for the linear regression, now in the final report we do the classification models. Here we did KNN, support vector machine, decision tree, naive bias, and let me start from the KNN. As you can see, like we copy our data set in the declassify, then we change our data set ability 365 into 0 and 1. We take 0 when ability is equal to 365, otherwise 1. We can see our data set is unbalanced. For 1, we can see there are only few data set, so we have to balance the data set, and we did balance by the smooth technique. Here you can see now our data set is balanced. Now it's ready to train our model. So before training the model, we have created a function for the ROC curve and the confusion matrix. This is for the ROC curve and the decision matrix, which we call for later by training after the training the model. Let's start for the k nearest neighbor, which is KNN. Here we use the sklearn library for the KNN, and we train our model, and after training we predict our model and get the accuracy of 92.16%, where we get the 1824 true negative and 2115 for the true positives, where 302 is the false positive and 33 is the false negative for the confusion matrix. And for the AUC score, we get the 92%, and this one is for the ROC curve, which means like user training accuracy for our KNN model. After that, we also calculate the error for the KNN model, and we get 0.048 for at k equal to 1, which means that when k equal to 1, the KNN models follows the trend of the training and get the training accuracy higher than the testing accuracy. So we get a minimum low testing accuracy than the training accuracy. After that, we have the logistic regressions. As we have also used the library for the logistic regressions, and we split the data set into 80% of training and 20% of testing size. And we also take the random step of 42, and we train the model with using the library and check the predictions. Here we get the accuracy of 78%, which is lower than the KNN model, and we get the confusion matrix here. And also for that we get the lower AUC score, which is 78. This is more similar to each other for the accuracy and AUC score, and we can also see that the training score or training accuracy is lower than the previous one. And from there my friend will start from here.
Yeah, before going to decision tree, as we are doing the empirical analysis of the data for the Airbnb data, we are we are calculating the F1 score, p-value, and t-test. And all after implementing all these, we have implemented chi-square test, which is the analysis of variance. After analyzing the variance, we came to conclusion conclusion that we have to implement ML classification models. In the ML classification models, my teammate has explained about the KNN, logistic regression, and other model. Coming to decision tree has a parent and child nodes. It has so many parent nodes and child nodes. In decision tree, it chooses the best parent node and child node, which gives the best accuracy. And for that, we have got the confusion matrix as like this. As we can see, the confusion matrix for the class 1 and 0. And the values ranging from 250 to 2000. And we got the accuracy of 96%, which is more than compared to other models. And with the precision of 97, recall of 95, and support of 2126. And our AUC score is 96. Coming to naive Bayes.
Yeah. Here in the naive base, again we are doing the training on the splitted data, and then we have printed the confusion matrix. So here, going to the results, so for this we got the accuracy of 63 percentage, and precision recall f1 score also. Then let's get into the AUC curve. As I said, we got 63.8 percentage again. uh, then can you just scroll down?
Yeah, coming to supported term machine, we have a hyperplane. Before going to hyperplane, we generally consider a line which we try to fit as a best fit line, but it doesn't work for the SVM because we use so many vectors. So for this data, we have a hyperplane and we plot a optimal line for this, which has a maximum range between the lines in the plane. So the data which is existing between these two lines is optimal, and and we can use this data for classifying or predicting the final output. And for this SVM model, we got an accuracy of 79. This doesn't mean the SVM is not performing well. For the Airbnb data, this model doesn't work well. Yeah, bro, can you scroll? Here
So
we have compared all the models.
So coming to the model comparison, we have compared the models against, here we can see in the graph. Can you just go down? Uh, yeah, here if we could see, we have taken all the models together: naive Bayes, logistic regression, KNN, ROC, sorry, KNN, and SVM. So if we see clearly, for the KNN, we got the high training accuracy, and for the decision tree, we got the uh, accuracy more, but for the KNN, we got the training accuracy, as I said, which is nothing but the testing. That's it. That's it for the comparison. Let's get into the documentation part.
Like here is the flow diagram of our whole projects. First, we collect the
Roshan,
data.
it's not sharing. Can you just please
Oh, it's
share?
not sharing.
Yeah.
Let me. Yeah, I think it's sharing. Yeah, now it's sharing.
Yeah. Yes.
Okay.
Go
Now
ahead.
this is the flow diagram of our whole projects. We collect the data set from the Kaggle, then we pre-process, like finding the missing value, and then we perform the statistical analysis, as my friend said about the one-way ANOVA, app test, t-test. We did all the things. After getting these, we split our data set into 80 to 20% training and testing. Then we perform the linear regressions and then build the classification model, and after building we deploy the model and get the prediction. This is the whole work of our projects, and this is the implementation part. As I mentioned, we balance our data set, then my friend Yamuna will continue from there in the result and discussion part in the last. Yeah.
So as I said, again here we have just taken
Just
the
scroll it up.
comparison. Can you just scroll it down? Yeah. So as I said, their code wise we have got the results same as we have taken the graph comparison over to the document. So so for the training accuracy, we got high for KNN, and for the testing accuracy, we got a high for the decision tree, which is 96 percentage and 97 percentage. So we also have printed the table here for the model comparison accuracies and AUC scores, as we see. So for the highest, we got 96.2 for the decision tree, and the next highest would be like KNN for 92 percentage.
This is all for presentation, and like we'll post in the GitHub, and thank you all.